We have been discussing about the data link layer. We have completed the aspects of the physical layer. We have moved to the higher level, that is data link layer. In the data link layer, we are sending the information in the form of the frames. Here, we are discussing about carrier sends multiple axes. What is this carrier sense? What is this multiple axis? You heard many multiple axis techniques. You have heard about time division multiple axis. You have heard about frequency division multiple axis, code division multiple axis in the communications. Similarly, here we have the communication channel. In the communication channel, the stations want to send their information in the form of frames. If we have 10 stations, these 10 stations are waiting to send the data in the channel. The problem is, if these 10 stations are sending simultaneously the information, means the frames, the communication channel will be with the group of frames from the 10 channels. There is a chance for the data loss. Whatever one station is sending for the receiving end, that same amount of data might not be received by the receiving station. There may be chance for the data loss and there may be chance for the time wastage, because of this collision the data might not reach in the same amount of time for the receiving end. To avoid these two, what we are calling as a collision is nothing but there is a overlap of the data. We are sending the data in the same amount of the channel, in the same bandwidth of the channel, we are sending the another station data. To avoid that, we are using carrier sense multiple axis. Carrier sense means we are sensing whether there is a carrier or not, whether there is a information from a station or not. We are sensing multiple axes. We are giving access to the multiple stations. Multiple stations can send the information in the same communication channel, but before sending the information, we are sensing whether there is a carrier, means whether the information from any station is present in the channel or not. That's why this is carrier sense multiple axis. So if there is no data in the communication channel from any station, then that condition we are calling as ideal condition, means there is no information from any station. How to detect whether there is a carrier or not? How to detect whether there is information from any station or not? By using an algorithm. By using this algorithm, we are trying to send, when there is no information, we are trying to send the data. If there is any information, we are not sending the data. Now we are discussing about three such algorithms. One is I persistence method, second one is non-persistence method, and the third one is p-persistence method. We have given the flowcharts for these algorithms. So algorithm is nothing but a group of instructions we write to detect whether there is a carrier in the channel or not. If there is a carrier, what to do? If there is no carrier, then what to do? If a channel is busy, we are using the same channel. When the channel is busy, if there is any information from any station, then another station has to wait until that information will be sent. Once the channel becomes free, then only next station has to communicate. This is what we are expecting. Then why we need these many algorithms? If this problem is very much simple, when there is a chance, you send. When there is a communication data busy, then don't send. Then why these many methods? We will discuss. First one is I persistence method. There is a data from station 1. That data we are trying to send in the channel. We are checking whether the channel is ideal or not. Assume if the channel is ideal, there is no data in the channel. Then the station can transmit. Per suppose, if the channel is busy, another station is already sending the data in the channel, then again we have to check whether the channel is busy or not. Again, if it is busy, again we have to check. This process is continuing. That's why it is called as high persistence method. Continuously this is happening. Until it finds ideal condition, it will continue in the iterative manner. Until it finds ideal. Until when it finds it become ideal, then it can transmit. Now what is the problem with this? The problem is when a channel finds it as when a station finds a channel as an ideal, another station may also find that channel as ideal. So n number of stations may find the same channel as ideal, and these n number of channels can transmit the data at the same time. Then obviously collision occurs. This is the problem with the high persistence method. To avoid this one, we are going to the non-persistence method. Here we are sending the data from one station in the form of the frames, and we are trying to check in the channel whether the channel is busy or not. If the channel is busy, if the channel is ideal, we can send the data. There is no problem. If the channel is busy, then immediately we are not checking. We are waiting for some time. Example, station 2 is waiting for 1 minute. Station 3 again, it found busy. It is waiting for 2 minutes. Station 4 is waiting for 5 minutes. This much amount of time it has to wait, because station 4 is asking in the next moment, we are giving more amount of time. You wait for 3 minutes. Like that we are increasing the time. Now what is the problem with this? Sometimes when the station 2 is, we are asking station 2 to wait for 1 minute. By that time, in half minute communication might have been completed by the previous channel. Now there is a wastage of half minute. Half minute wastage means that is a very huge amount of loss for the communication channel. This wastage is the disadvantage of this non-persistence method. Definitely there is no collision with this method. This is advantage. Here there is a possibility of the collision, but there is no need to wait. This is the advantage. Advantage is no waiting period. Disadvantage is highest chance for collision. Here the advantage is there is no chance for collision, but the disadvantage is wastage of the bandwidth, waiting time. You are wasting the precious channel. So to avoid that one, we are clubbing these two techniques and we are bringing one more P-persistence method. We are sending the data from a station in the form of the frames. We are checking whether the channel is busy or not. If the channel is busy, again it has to check. Again it has to check. Again busy, again it has to check. Persistence. This is non-persistence. There is no need to again checking. Wait. That's why this is non-persistence. This has to check again and again until it finds it is free. If the channel is ideal, then we are not asking it to send data immediately, because we already came to know what is the problem if we send the data immediately. If the channel is ideal, then we are saying we are giving a probability to that station. Example, for station 2, probability 0.6, for station 3, probability 0.2, for station 4, probability 0.1, for station 5, probability 0.05, for station 6, probability 0.04, for station 7, probability 0.01. All these if you count, finally we will get 1. Now we are asking whether which one is having the highest probability. Which one is having the highest probability? Station 2. Because the probability of station 2 is greater than all probabilities, this station 2 can transmit the information. Remaining all stations, we are asking them to wait. Immediately we are saying to transmit. There is no wastage of time like here. We are giving probabilities, and highest probability one, immediately you transmit. And after the completion of this one, remaining they are waiting. Remaining after they are continuously checking whether they are ideal or not. After that, if it is busy, again continuously checking. When it becomes ideal, then immediately the probabilities will be generated, and next time immediately in those probabilities, whichever is having the highest probability, that station can transmit. That's why this method is called as probability persistence method. We are combining the advantage of there is no need to wait for much time and there is no chance for the collision. We are combining these two advantages and bringing out P-persistence method. Our final aim is we have to transmit the frames in the communication channel without the collision. That's why this is called as carrier sense multiple axis. Without collision we have to send. CD is nothing but collision detection. The collision should not occur. We have to transmit data without collision. These three algorithms we are using. Now you tell me, in carrier sense multiple axis, how many algorithms here we are using? 3 algorithms. What are those? I persistence method, on persistence method. Out of these 3 methods, in which method there is a chance for highest collision? In which method there is a chance for highest wastage of time? Which is the best method out of these 3? P persistence method. P means probability. Okay. So here, whenever I am referring to data, what is that data? Frames. Okay, because we are discussing about the data link layer.